Hello, I am Neeraj. Today I will try to explain the Mamba architecture, basic Mamba architecture, also known as maximum memory attention with multiplicative bias architecture. Like the traditional deep learning architecture, like we use LSTM or transformer, we provide some data as input and then we get some patterns as output. And we use those patterns for classification or some sequence to sequence predictions or any different kinds of tasks. Similarly, we can use the Mamba architecture also. But before going into the detail, first we have to understand that how Mamba architecture transfers the data into pattern and what are the characteristics of those patterns. So different from other architectures, Mamba architecture contains some predefined stages. So once we get the input data, we pass this data to 1D convolutional layer. The main purpose of this layer is to get the contextual information. Actually, what happened when we already we know from the if we have a background knowledge of CNN or some kind of architecture, we already know that when we pass or achieve the 1D convolution with the help of 1D kernel, then we use sliding window type of movement. And when suppose we are reaching here with this kernel, and then when we get the output 1D convolution output for this element, we will have nearest neighbor information also. Similarly, if we have a kernel of bigger size, we will have more nearest neighbor information. This type of information helps in a lot of different ways. For example, suppose sentence contains some negation, or suppose we are handling some time series data, then it will capture some spike related pattern. So many changes in the patterns will be captured through the convolution. And why it is beneficial, like suppose we are using LSTM type of architecture, then what happens in the LSTM type of architecture contains the information in a long sequences, and suppose we want to get something here, we have to consider all things that already occurred earlier. If you are using one like a traditional LSTM architecture, not bidirectional, and in bidirectional we have to cover from both directions. So it adds a lot of computational overhead and creates problem in parallelization also. So this is the simplest way to achieve or catch or capture the contextual information in the data. So this is the first part. So once you capture this contextual information about the data, the next part of the Mamba architecture is state space model core. The state space model core is just working like it controls the memory. So how it controls the memory? Suppose you have something, here you are getting some information that is coming from your current state that we identified as JT. And suppose some information is coming from your previous state like ST minus 1. That is your state space states. And this is your current state space state. So for simplicity, just consider these states like a LSTM block. So in this case, the state space model core decides which part of the memory from the past state we can maintain or retain, and which part of the memory of the current state we can add, and then it combines both the information. This way it gets the most useful information from the past and from the current. So this is the main role of state space model 4. So first phase we have captured the context. Second phase we decided which part of the memory is useful, which are not. And third part, just to consider that you have read the complete book and now you have to return the book. So you will try to preserve very important informations about the book so that you can reuse it in future cases. So for this they are using multiplicative bias or gating. So this multiplicative bias or gating is actually achieved through perceptron, single perceptron layer or single perceptron. This perceptron contains summation layer and a sigmoid layer. Sigmoid layer is very important because it returns value between 0 and 1. And this value 0 and 1 decides that which part of the which of those means memory states are useful for next stage or which of the memory which part of the memory is not useful for the next stage. Now what after that the system do now what the system does after that, so here you can see that this is state space st. So they just calculate the point-wise multiplication of that state space with the get vector that is achieved through that learned perceptron layer. And based on that multiplications, we get the important and useful patterns. And after that, it identifies the output projections. Output projection is just a linear kind of layer. So you can get the value and this will be the final output. So now you can easily able to understand that how Mamba architecture actually works. First, it captures the context by using 1D convolution. Next, it try to identify what are the informations which are useful, which are not useful according to different states. After that, it captures the it just selects or the useful memory from the state memory collections, and after that it just projects the final patterns which are useful for your applications, and based on that you can do your application. And the number of states, you can select any number of states based on the capacity of your GPU or architecture. Generally, people select 16, 32, 64, different states like we select with LSTM architecture. So this is the basic of Mamba architecture. Now we will try to understand this through a very simple example.